Welcome to Chapter 5. We are starting here in Section 5.1, Estimating Area with Sums. So this is something a little different. The big question here, as you can see, is going to be how can we find the area under a curve? And by curve there, we just mean the graph of a function. As you can see from some of these graphs, they might not necessarily be curvy shapes all the time, but the area under a curve is just meaning the area between a function's graph and the x-axis. So to start it out here, we've got just a pretty simple function, the function f of x equals 4. If you zoom in here, you can see that that's 4 right there. So we got a line for that function's graph. So we want to find the area underneath that function's graph under f of x equals 4 from x equals 1 to x equals 6. So let's mark those off. Here's x equals 1. Coming through right there. Here's x equals 6. Okay, so we are looking at this area right here. Okay, and we can see that this area is just the area of a rectangle. So that area is going to be length times width as usual, or width times height if you want to think of it that way. I'd say the length of this would be like L would be the dimension going this way. And then I'll say this is W going this way. So our L is 4. And then our width W would be the difference between 6 and 1. So that would be 4 times 5, and that would give us 20 units squared. Okay. So the 20 is what we're really wanting to focus on here. All right, so that was just the area of a rectangle, simple enough. Let's complicate our function a tiny bit here. We are gonna not have the formula for this function, but it's a piecewise type of thing. Its graph is given here. We have a horizontal line, so f of x equals 4 for a certain portion of this function. And then it goes into a slanted line for the next piece. We want to find the area under this curve, or this function's graph, from x equals 1 to x equals 8. Okay, now be a little bit careful. The main grid marks here, the darkest ones, are counting by 2s. So from x equals 1, that would be right here, to x equals 8, that would be right there. And so we are looking at this area underneath here, all of this. Okay, now that's not immediately a shape that we have a formula for, but you can see that if we split it into 2 different pieces, we can easily come up with the area of each portion of this graph. All right, so this large area here is just another area of a rectangle. Okay, so that would be another length times width situation here. Length or height of 4. Width this way would be 8 minus 1, so that's 7 units in that direction. So we have a rectangle that is 4 by 7. All right, so that's 28 square units for that lower portion. And then up here for this little triangle, area of the triangle, I'll say there, that would be 1/2 base times height. And so the base of that triangle, if we look at our values, the base is 2 units and the height is also 2 units. So 1/2 of 2 times 2. would just be 2 square units for that little piece of triangle there. So for the total area underneath our curve, we take the big rectangle, 28 square units, and add the little triangle, 2 square units, and so we'd get 30 units squared. Okay, so part of this is, if it's a recognizable geometric shape, we do still need some knowledge of geometry here. But if it's a recognizable shape that you know the area formula for, then you can just use that area formula and calculate it. Now let's look at our next shape here. We're going to look at the area under f of x equals 1 minus x squared from x equals 0 to x equals 1. So this is a graph of that function here in blue. That's a parabola, 1 minus x squared. So parabola opening downwards, vertex up here at 0, 1. And from 0 to 1 is really just the portion graphed right here. So this is the area that we want. All right. Now, if you happen to know a formula for the area of a parabola type of shape, then sure, you could go ahead and use that, but I'm kind of doubting that anybody knows the formula for this area off the top of their head. So we are going to come up with another way to get at this. And that is where the title of our section is going to come in. Estimating area with sums. So right now we are not going to find the exact area underneath this curve right now. We are going to estimate it for starters. So this is going to be just an approximation. Approximate and estimate. Okay, so we can kind of narrow down the area beneath this curve here. Notice how our parabola, again, has a y-intercept of 1 and also an x-intercept of 1 here. And we're just looking for that area underneath. Notice how that does actually sit within a, whoa, that was a large pen. That does sit within a 1 unit by 1 unit square on the graph. Okay, so that would be 1 unit squared for that little orange square that I just drew. That's this square right here. We can see that our area shaded in green there is less than the area of that square, clearly, right? So our area must be less than 1. Area is less than 1. We can tell from that. Okay, so visualizing that square helps us estimate what the area is going to be. It's less than 1 unit. What if we took that idea, though, like of forming a square, and we made 2 squares here instead? Although when we make 2 of them, they're not really going to look like squares anymore. They're going to look like rectangles. So let's do something like this and form 2 rectangles that will contain the shaded area that we want here. Okay, so we're going to approximate now by using the area of these 2 rectangles, because rectangle areas are really quick to calculate, as we've seen. So for our first rectangle here, number 1, we're going to have a width here of half a unit. See how that goes to 0.5 there. Half a unit there. And then the height is 1 unit. All right, and goes all the way up to the top there. Okay, so width times height, 1/2 times 1. And then we would add the second rectangle here, 2. And its width is also 1/2 a unit. It's that other portion there. And now we need the height of the second rectangle. So we're looking for this. And the one thing we can use for this is to notice that we've made the second rectangle based on this point right here. And that point right there, we can actually find a value for because that point lies on the parabola. And it is the y value that goes with the x value of 1/2. Okay, so the y value for that circled point is f of 1/2, and that's going to give us the height of our second rectangle. Okay, so a little quick side calculation here for f of 1/2. That would be 1 minus 1/2 squared, 1 minus 1/4. That would be 3/4. Okay, which, yeah, that looks pretty reasonable based on our graph there. Okay, so this is going to be 1/2 times 1 plus 1/2 times 3/4. And so we're going to get 1/2 plus 3/8. And so we'll combine those together. Whoops. And we'll end up getting an estimate of 7/8 square units. Okay. So that is our new estimate for this area. But as you can see, kind of like we saw with our square here, our 1 unit square, the actual area that we want, the green shaded area in the picture, area beneath the parabola, is still less than the area of those 2 rectangles put together, because those 2 rectangles have a little bit of overhang that we don't actually want here. So the 7/8 estimate is including those orange shaded areas. So this is not the actual area beneath the curve, but it does give us a better estimate. Okay. So area, we could say, is approximately 7/8 or 0.8, whoops, 0.875 would be the decimal for that, by the way. But it's still overestimating the area. Our actual area is still something less than that. Okay, this is an overestimate. Okay. So that gives you an idea of what we're going to be looking at here, approximating an area with rectangles. We can see this is an overestimate right now. In the next video, we're going to take this idea and refine it a little more, look at some different ways of estimating with rectangles to see if we could narrow down our estimation at all here. So see you in the next video.